Okay, so the internet says that the answer to this question is 1. Let me explain to you how they got that answer, and then I'll explain to you why I don't like their proposition. So do we have the equation for function f? No. Let's assume that it's a linear function. Y equals mx plus b. Good old y equals mx plus b. Now we know that if I plug in -5, let me plug in -5. But I know what f of -5 is. That's 7, so 7 goes in here. Let me add the 5m to that side. And so I have an expression that represents b, and let me plug that back in here. Now, I know that f and g are inverses. In earlier levels of math class, they told you that to find the inverse, you switch x and y. So over here, let me find the inverse by switching x and y. And then why don't we get this y by itself? So I'm going to go x minus 5m minus 7 equals my. And then to get y alone, I can divide both sides by m. Now really, since this is the inverse of f, I really shouldn't call it y. I should call it g of x. So g of x equals x over m minus 5 minus 7 over m. So right now, I have an equation for f of x right there, and I have an equation for g of x right here. Let me sort of clean off my whiteboard. So here I have my equations. This is f of x and this is g of x. And I want to show which of these is false. So notice that all of these involve f prime, f prime, f prime, taking the derivative of f. So if I take the derivative of f, maybe first what I can do is find m. Once I know m, then I can find the derivative of f. So what I'm going to do now is I'm going to find the derivative of g because I have something that is on the derivative of g. So here, let's take g prime. So let's see, so g prime of x would equal, well, there is a 1 there. And so that would be 1 over m. And then just like that, because the derivative of x is just the coefficient 1 over m. And this is 0 and this is 0 because these are constants. So this is the derivative of, so this is g prime, okay? Now I do have a point on g prime right here. G prime of 7 equals 3. So let me plug in 7 in for x. And there's no x to plug into. So it's just gonna be 1 over m. Because if there was an x, I would plug in 7, but there's no x, it's just the number 1 over m. But I do know what g prime of 7 is. G prime of 7 equals 3. So I have 3 equals 1 over m. And then I can multiply both sides by m, these are gone. So I have 3m equals 1. And this tells me that m equals 1/3. How come this is important? Because m is 1/3, which means that I can go to my equation for f. And instead of m, I can plug in 1/3. Instead of m, I can plug in 1/3. And now why don't we finish this problem by taking the derivative of f. F prime of x equals 1/3, because that's just that. And this is a number and this is a number, so this is the derivative of f. And look at what this is saying, right? Look what this is saying. This is saying, regardless of what you plug in for x, your f prime of that number is always going to be a constant 1/3. So that's why this is possible because it's 1/3, and this is possible because this is 1/3. So this is impossible because the derivative will be a constant value of 1/3. So that's why the internet says that this is the correct answer, because this must be false because the derivative of f at any number is always going to be 1/3, which is why these guys are okay and which is why this is false. But the reason that I don't like this is because this version assumes that f and g, it assumes that they are linear. Y equals mx plus b. Isn't that how we started this video? Assuming that y equals mx plus b. How do I know that f and g are inverse, are linear? I don't know that f is a linear function. All that says is f and g are inverses and that they're differentiable for all x values. Bro, nowhere does it say that f and g are linear. But I think that the internet says that this is the answer because the internet assumes that f and g are linear functions. But I just don't know that. So I don't like how they got that answer, but I think this is how they got that answer. And when I tried this problem yesterday, I got option 3. I looked over my video and there was a technicality that was there that shouldn't have been there, which is why I deleted that video. So that's how they got this one here. But if in class, if you find a different way of doing this problem, then please educate me and please come to me and let me know what you did in class. If it's something other than this, I really, really, really want to know.